should be alright, and I wish it could. See, I don't got...
Hello. There we go. So this is my first time on stage, so that's awesome. And I'm super nervous, so bear with me. Thank you. Which is weird, because I know all of you. So this is great. So good afternoon, everyone. Welcome to Geeks Speak. I want to thank all of you for continuously coming here each month to support your peers. We have an awesome presentation for you today. We have, please welcome Michaela Karen to the stage for her presentation, Git With It.
Hello. Okay, so the mic works. So I had to come up with a name for the presentation. So the second best thing I could come up with was Git With It. So if you want to hear the first one, let me know later. And let's get started. So this is a comic I found because I was like trying to find a really good meme about it, but it only makes sense if you actually understand what Git is. So if you read through this and you laugh, you know enough that you've done it. So, my name is Michaela Karen. I started here in January, and my title is iOS Special Projects Engineer. So the special project that I'm working on lately has been all of the conference room QSys stuff. So when you go in, you have the touch screen. That with the camera, speakers, mic, I've been setting like all of that kind of stuff up. But I think Git is really interesting, so that's why I decided to talk on it. So first, what is Git? It's what's called a distributed version control system. So we'll say what that is, but also, fun fact, it was created by Linus Torvalds, who's the same guy who created the Linux operating system. So what is Git? What does distributed version control system even mean? So when you begin programming, you'll have some kind of file. So like, for example, mainview.swift. And then you're like, OK, this is a good file. Like, I like this. But then somebody comes up and is like, hey, let's add this brand new feature to this. So you're like, OK. But you don't want to lose any of the progress that you have at this point. So you create a new file, just mainview2. So then you have a copy of your old one. You're like, OK, I like what's going on. Somebody else comes up, says, you should add this new feature. So of course, you have to create another one because you don't want to lose the progress from the other feature you were working on. And you're like, OK, I really like what's happening, but maybe we can like just add like a little bit more to make it like a little bit more interesting. So then you finally have your mainview final file. And this is it. Like, you're not going to change it. But then, of course, you have your BA come up to you and be like, but can we like squeeze this one feature in just before we go to production? So you have to create your mainview final file. So what Git does is it helps you keep track of all of these different versions of your file. Because you can't have 4 or 5 different copies of a single file. When you're programming, you'll be changing multiple files at a time. So what Git does is track your different versions. So you don't have copies of all these files anymore, and all you have is your single main view file. And you can see the differences throughout the different versions. Git is also used heavily within teams. So you can have a single code base, and your entire team can work on that code base together. And you don't like have too many issues where people are running into each other. And it's basically so multiple people can work on a single code base, where you have like your code on your computer will not affect somebody else's code on a different computer. So what does it really look like using Git? So you start off programming. So here you are just programming along. And you think your code is at a good point where you want to save it. So you go ahead and save your code. So this is what is called a commit. So now you have one version of what your code looks like. So you go on, keep on developing. You make a new commit. Then as you go along, you write like new features and just add a couple things. You just keep on committing. So you just continually commit different points of your code. So at any time, you can always go back and see, what did I do at this certain commit? So as you keep going, you keep on coding, And then, of course, you always have to add that one last feature. But then somebody comes up to you with this like crazy idea, and you're like, oh, I don't want to mess up everything I already have at this point. So you want to create like a completely different version of your code. To do that, you create what's called a branch. So it's like Mario going down. And then now you have a completely separate branch of your code. So this is called branching. So now the code that you're continually committing on this branch does not affect any of the code on your previous branch. And then you have to add one more. So this is what branching looks like. So you start to see like a kind of graph theory of this. So that's where that comic comes from. So this is where you have all these different branches, and it looks like a big spider web. But to break it down a little bit, you have your main branch. So this is like your main code base and what is in production at the moment. You create a develop branch or a development. So this is where you're actively like developing the new features, and like this is stable code that will go into the next feature, but it's not in production just yet. You have your new features. So every developer can have their own feature branch, or even one developer could have multiple feature branches. And then lastly, you'll have a hotfix branch. So this is like, oh no, we found a breaking change in production, like it's failing every single time a user does something. And then that's where you create a hotfix, and then that will go directly back up into production afterwards. So you end up with the spider web of everything. But you can see like the hotfix branch, after you create a commit, it goes directly into production, into main, and then also goes back into development, because your development branch most likely, probably, needs that fix as well. So how do you go about actually using Git? So you think of it as a tool. So you can use this tool in different ways. So you have the terminal, so you can type commands for everything, and then that's how you use it. Or you can use a GUI, which is some kind of graphical interface where you just point and click, and that will do the commits for you. So when you hear Git, you kind of can't get away without hearing GitHub or GitLab or something with the name Git in it. So they're all different things. So you have GitHub and GitLab. These are what are called remote repositories. So this is where you push your code to like some other location. So it's on your computer and on GitHub, GitLab, which is some other place. So this is creating basically a backup of your code. So in case you ever do something wrong on your local computer, then you can just clone down a new copy from GitHub or GitLab. And essentially, these are the same thing. Like, yes, they're different products, and they can do different things. So like, GitHub calls them pull requests, whereas GitLab calls them a merge request. But it's pretty much the same thing in basic terms. But like any other competing product, they'll do, like, one can do one thing, one can do another, etc. So when you're actually using Git, the workflow looks something like this. You'll start out in what's called the working directory. So this is where you are actively like coding along, like building your project, trying to make some kind of feature. When you're ready to begin like committing your code, you need to move files from your working directory over to your staging area. So this is where like pretty much the files that are on deck, you're ready to be committed, this is where it would go. So you can see, you can pick and choose which files you want, so you don't always have to commit every file you're currently changing. You just pick which one. And then after that, at that point, that is where you go about actually making a commit. So now that you've committed the code, it is saved in what's called your local repository. So your local repo is like your computer. So you have like your entire code base, and it's all sitting on your computer, and you make different commits, and it's to the place called your local repo. And then lastly, you have your local repository and then the remote repository. So your remote is like something like GitHub or GitLab. It doesn't necessarily need to be the internet, but it just needs to be some place that is not your computer. So like at a lot of companies like here, your remote repository is just a different server, but it's on-prem. So to get code from your local machine up to the repo, you have to push it. And then after you have pushed code, you have all the developers pushing code to the remote repository. Well, eventually you will need those code changes back onto your computer so you can build off of other features. So to get the code back down to your computer, you have to pull it. So using Git, you can see, you can use this with your entire team. So your whole team can push and pull from your remote repository, and you can all have like your own copy of the code base and not have to like get in each other's way. So let's go to the demo this time. Uh-oh. And this is what it looks like. This is after you mess up, you have to just delete it all. No, it's already awake. There we go. Okay. Okay. So this is just a basic iOS developer project. So if we run this, we just get text across the screen that says "Hello World" if it runs. It's slow sometimes. There we go. Okay, so that's what the project looks like. It's just text, "Hello World." So let's create our Git repository, because when you make a new project, Git doesn't automatically just exist. You have to create it. So you type git init, and that will create a repository for you. I already did this for this demo, so that's why it says already initialized. And then by typing the command git status, you can see like what's happening. But before we start committing our files, we need to use something called an ignore file. So you have some files within your project, like build files that get generated every single time you run the project, and you don't want to commit those every time. So you can create what's called a git ignore file. There is like this website called gitignore.io that can automatically create these for you. So you just type in like a couple things about like your environment. So we're using Xcode. We have a Mac, and then we're using the Swift programming language. So let's click create. So you have files like this, like dsstore, which is a macOS like meta file. We don't really need that. And a bunch of other ones. So let's first create a new file. So this is just a command line to create a new file. And then you can open it with like any text editor that you want. I'm just going to use Vim, because it's easy for a simple demo. So that was just pasting everything into this new file. So now, typing git status, we see our new file is one of the ones that are not tracked yet. Let's commit this file first, because that has to take effect, and then it'll work after that. So typing git add, and then the file name. This adds it to that staging area. So when you type git status again, we see these are the untracked files in our working directory. Then now we have a file in our staging area, and then now we are ready to commit it, so let's commit that. So git commit is the command to do this, and then -m is a message. Because when you make all these different commits, you need to know, okay, what was even happening at this point in time? Because when you go back 6 weeks, 6 months later, you'll have absolutely no idea, even if you wrote it. So if we type git commit, and then the message is add git ignore. So it tells us one file was changed, 135 insertions, so that's how many lines, and then we actually created it. So by typing git status again, we can see the file is now gone out of the staging area because it's been completely committed. So let's commit everything else. So by typing git add and then a period, that adds everything that's in the project, rather than having to type it line by line. So typing git status again, we can see here are all of the different files that we want to add. So to commit them, so you write git commit, and then let's just call this initial commit. So now we have files that are committed into the repository. Let's actually bring that back up. And they are in our local repository. So that exists on my computer and my computer only. It's not anywhere else. So let's add that to a remote repository, which for us is GitLab. So to do this, we need this SSH, which is basically just where is your repository at. So to this, we have to add our remote repository to our project. So git remote add, and then you give it a name. Typically, it's called origin, but you could really call it anything you want. And then you paste in the link. So now when we type git remote, we can see that's the remote repository, and then that's the location for where it's at. So let's push our code. So git push origin main. So if you had multiple branches or multiple different remotes, you have to specify exactly where it's going. So we specified the remote and which branch. Hopefully this works. There we go. So that's just saying, hey, we pushed everything up to a remote repository. So when we look at this web page and refresh it, we now have our code that's in the remote repository. So if I just deleted the project off my computer, you can reclone it back down to your computer. And that's why that comic is funny. And if you're laughing, I'm sure you've done it too. So that was using terminal. Let's minimize that. And this is some kind of GUI. So my favorite thing about Git is all the names of everything, because Git is just easy. So this one is called Git Kraken, and their logo is the Kraken right here. So that's my favorite one. So let's change some of the code that we have here. So instead of typing a boring hello world, look how fast I can type. This is a code snippet. This is just a new little example that I found. So we have a beautiful button that says, welcome to SGS. And if you click on it, we have confetti. So let's commit this, because we like where the project is at this moment. So we go into here, and we can see there's our 2 previous commits that we had, and then we have this work in progress. So this is showing us in a user interface, here's our working directory, this is our staging area, and then this is where we actually go and make a commit. So let's commit this file, stage it, called content view, and when you click on it, you can see the differences for what happened. So you can see previously there was a line taken away that said text hello world, and now we have everything else that makes that button. So if we go to commit it, let's say awesome button for SGS. And then we just click a button, and now all of our code is committed, and it's doing the exact same thing that we did on the terminal. So let's push that as well. So if we just click on push, where do you want to pull from? We don't want to do that. Let's just do it on the command line, because it doesn't ask you. It just does whatever you want. Oh my gosh. So there we go. So now we've pushed all of our code for this. But let's start creating a new feature. So to do that, we want to make a new branch. So you just type git branch and then give it a name. Let's just call it feed. And then now let's push our branch up to the remote so that you have a copy of it on your computer in case you mess anything up. You always have a copy on your remote repository as well. And then if we go back to GitLab, refresh this, it says now we have 2 branches. So let's make some changes. What is your somebody yell out like your favorite emoji. Rocket. The rocket. Anybody else? Dolphin. I heard one more. Oh, where? So we have all that. We rerun our project. And then now we can see all of those. So let's make a new commit here because we like what it looks like. And then you can see it still says we're on the main branch. And then actually I made these changes on the main branch, so hopefully this works. So if we need to move over to our feature branch because we created it, but we never actually moved over. So hopefully this works and I don't have to do git checkout feature. Okay, yeah, it moved everything over, which is good. And you can see now it says feature, the one that we're on. So by typing git status again, here's our one file that we changed. Let's add it to the staging area. So typing git status again, we see now it's changes to be committed. And let's commit this file. Git commit new emojis. Oh my gosh, I didn't put a quote on the other end. And no, did I spell commit wrong? That's why. You have to spell things right to program, but only on terminal. If you spell it wrong in your code, you just have to continually spell it wrong. So now we have a new commit with this. So let's change the size because that will be more exciting. Let's make it 80 and see what that looks like. There we go. That is beautiful. So typing git status again, we can see we still have that one file that we've changed. And then with git kraken, you can see the difference. You can do that with terminal as well. You can do all the same things. It's just write a command to do it or click buttons to do it. So let's commit this. Git commit. Did I add it though? I'm not sure. So if you type AM, that's adding it to the staging area, which is anything that you changed, and then also committing it all at the same time to save you keystrokes, which doesn't really matter that much when you program because you're typing all day though. So we change the size. So there we go, we have that. And now let's merge all of our brand new feature that we have and merge it back into main. So to do that, you create what is called in GitLab a merge request. So if we go into here, it already knows, hey, you just pushed to feature, which I don't remember. Git push, origin feature. Yep, no I didn't. So now we have push to feature. So we go up here and click create merge request. And then here's where you would actually start typing a title, what everything does, and you can add code reviewers because you want other people to look at your code, because no matter how great you think it is, it may not be that great. So let's click submit merge request. So if you are working with other developers, you will 100% of the time at some point in your life, most likely one of the first times you use Git, see what's called a merge conflict. So let's see, what does this say? Resolve conflicts. So that's what it looks like. Let's first go into our feature and do this like in the actual IDE because it's sometimes like easier to read. So let's pull from main, so git pull origin main, and pull that into our feature, because that's a typical workflow that you want to do, is you don't want to just push your code and try to merge it immediately, because somebody else on your team may have pushed their code into that base. So you want to have the most updated changes before you try pushing your new feature. So if we do this, it gives us this big printout that says watch out, you're doing something scary. And it's basically saying, we have a merge conflict. So it looks kind of weird, and it basically makes it so your code, it can't do anything, it can't compile. So what it looks like is, we want to merge our feature of this one, so this is the code line that we wanted to merge, but there's already a commit here of somebody else changing this. So when two people try to change the same line of code, Git isn't smart enough to know who should do that. So then you have to resolve the merge conflict of, okay, I want to use this line, or sometimes it is you want to use both of them. But let's just use mine or not mine. For now, we'll use the one that our teammate had, because 50 is probably more acceptable than 80. And then you should always then build your project again, because you can resolve a merge conflict with Git, and then everything could be completely fine, but could then break your project. So make sure you always build it again. See, does everything continue to work? And it does. And then let's go ahead and commit this. So we're in the middle of trying to merge code because Git's what's going on? So once we do that, you have to then commit your changes so Git knows we fixed everything. So if we type git add and then git commit, it's telling us, let's merge this, and we're like, yes, that's what we want to do. And then now it has been committed. So if we push our changes back up to GitLab, we can automatically go to our merge request, just open it again, and see, like, it updates and told us, like, we have these 2 commits. Hey, everything is good to merge. So you click a button, and then now all of our code has been merged on main within our GitLab project, and then that's where you would pull it back down to your local computer and continue, like, deleting that branch and making a new one and continue coding. So that's the demo of how it all works. And then we have one last topic to talk about. So if this is how you felt throughout the entire thing of me just typing commands and you not knowing what happens, that's okay, because I did that before too. And that's a big thing with Stack Overflow is you'll just copy something and hope that nothing messes anything else up. And then lastly is CI and CD. So what that means is continuous integration and continuous delivery or deployment. So what does that look like? So continuous integration is the practice that involves developers making small changes and checks to their code. So the small changes are the commits that you're making. You want to make very small commits, so at any point in time, you can always go back to that very specific point and figure out what happened. Because if you create a new commit and change like 1,000 lines of code, you're not going to know 6 months later what your thought process was or what you were doing. So making small commits helps to very incrementally go back and see. And then also, it's about combining good code together. So when you and your friend are both working on the same project, it's easy for you guys to just continue coding along and never talking to each other, and each of your branches are working perfectly fine. But when you continuously combine your code together, and then we'll make a beautiful product in the end, and you can continue coding along and having a great software product. And then with continuous delivery and deployment, it's about the automated delivery of completed code. So the big advantage with this is you don't have to have somebody clicking a button at midnight, be like, okay, push the code changes now. You could just have that completely automated with a branch, for example. So anything that is merged into main, that automatically gets pushed up into production, if that's what you want. It depends and changes depending on what language you're using, what your workflow is. There's a lot of things you can do with that. And it also helps with creating a better product, because if you and your teammate are both coding along, you could just continually code, and with continuous integration, you may be writing really good code, but the code you're writing is always for someone else. Rarely do you write something that you end up using, but you always have some end customer in mind. So if you code along for 6 months and never tell the user about what you're making, the user comes in and then completely destroys everything that you wanted to do. So when you have continuous delivery and deployment, you go through this loop, which is a basic example you see in everything, of your code just continually goes through this loop. You have smaller feedback loops so that the product that you're building in the end is what your end customer wants. So then at the end, remember, if there is ever a fire, you just need to git commit, push, and then get out. Thank you. So for anybody asking any questions, there's 2 microphones up at the front. You can either walk up there or shout really loud, and I'll repeat your question.
What's better, Git rebase or Git merge?
I will give you. Yeah. It's Git clone. But it's Git rebase and merge are a common way of combining code. And like any good programmer, it depends on what you are doing. So sometimes with Git rebase, you could be developing a huge feature for an open source project, and you can do what's called squashing. So you can take, for example, 20 commits that you have, you can put them all into a single commit and then push that to an open source project because they don't care about all the 20 commits that you had. So with that, you could use rebase, or Git merge just merges whatever you have directly into that source branch. Anybody else? Are you ready for the last animation?